Hello 7th graders, this is Miss White, and today we're doing Lesson 10, Angle Problems and Solving Equations. Here we're going to recall the definitions of adjacent and vertical and the facts regarding angles on a line and angles on a point. If an abbreviation exists, we should include the abbreviation of the angle facts under the name of each relationship. In the angle fact column, we are going to write the definitions and practice the different angle notations when describing the relationship in the angle fact. Let's start with adjacent angles. So we have two angles. We have angle BA and C and angle CA and D. Both of these have common sides, which is AC, and they're adjacent angles if C, which is here, belongs to the interior of B, A, and D. So angles A and B are adjacent angles. So angle BAC and angle CAD are adjacent angles. Go ahead and pause the video if you need more time to write this down. Alright, now let's look at vertical angles. Two angles are vertical angles, or vertically opposite angles, if their sides form two pairs of opposite arrays. So that means that both angle A and B are going to equal the same thing. So for example here, I have angle CDF equals angle GCE. Please pause the video if you need more time to write this down. Angles on a line. The sum of the measure of two angles that shares a ray and forms a line that equals 180. So A plus B is going to equal 180 degrees. So angle ABC plus angle CBD equals 180 degrees. Go ahead and pause the video if you need more time to write this down, and let's start to look at angles at a point. The measure of all angles formed by three or more rays with the same vertex of 360. So here we have A plus B plus C, and that's going to give us a total of 360 degrees. So here I have angle BAC plus CAD and angle DAB. All these angles together are going to give us 360 degrees. Now let's look at example 1. It says estimate the measurement of X. X is here. In a complete sentence, describe the angle relationship in the diagram. So the two angles I see here are BAC and CAD. And so these are angles on a line, and their measurement has a sum of 180. Now let's write an equation for the angle relationship shown in the figure and solve for X. Then find the measure of BAC and confirm your answers by measuring the angle with a protractor. Well, we are not going to confirm your answers by using a protractor. We're just going to go ahead and solve this algebraically. So first of all, I know that I have X, and I'm going to add X to 132, okay, because these are the angles measurements that are given to us. To find X, I know that both of these equal 180 degrees. So now what I need to do is I need to get X by itself. I'm going to subtract 132 from both sides. So now I have x equals 180 minus 132, and that's going to give me 48. So now I know that the angle BAC equals 148 degrees. All right, let's move on to example 2. In a complete sentence, describe the angle relationship in the diagram. So here we have angle AE and L and angle LE and B. And the angles are on the line, which means that their sum measures up to 180. Angle AE and L and KE and B are vertical angles and are of equal measurement. Again, here are angles A, E, and L, and then here is angle L, E, and B. Both of these angles together equal a sum of 180. Now, A, E, and L and K, E, and B are vertical angles and are equal measurements. Example 3. In a complete sentence, describe the angle relationships in a diagram. So first, I know that I have G, K, E, and I have E, K, F, and G, K, F. Okay, all these angles together equal 360 degrees. Great. So now let's write an equation for the angle relationship shown in the figure and solve for x. Find the measurement of E, K, F, and confirm your answers. And we are not going to measure by using a protractor. So how I'm going to start off this problem is I'm going to have x plus my 90 degrees here plus 135 degrees. And I know that all these angles together equal 360 degrees. So now when I add what I know together here, 90 plus 135, I'm going to get 225. So now I have x plus 225 equals 360. Now to get x by itself, I'm going to take away 225 from each side. So I have x plus 225 minus 225 equals 360 minus 225. So now I have 225 minus 225, and that's going to give me 0. So now I'm going to have x plus 0 equals 360 minus 225, which is going to give me 135. So now I know that x equals 135 degrees. Example 4. The following two lines intersect. The ratio of the measurements of the obtuse angle to the acute angle at any adjacent angle pair in this figure is 2 to 1. In a complete sentence, describe the angle relationship in the diagram. So the measurement of an obtuse angle is twice the measurement of the acute angle here. So how we're going to represent that is we have 2x for our obtuse angle, and our acute angle is x. So for the complete sentence, we're going to have the measurement of an obtuse angle is twice
that's 10 and that's 12.
the measurement of an acute angle. In this diagram. Now label the diagram with expressions that describe this relationship. Write an equation that models the angle relationship and solve for x. Find the measurements of the acute and obtuse angles. So here we have both of our x's, and we want to try to figure out what x equals. Here, I know that this line equals a total of 180 degrees. So I'm going to have 2x plus x equals 180 degrees. Then I'm going to combine my like terms. So I have 2x plus x. That is going to give me 3x. So now I have 3x equals 180. To get x by itself, I'm going to multiply it by the multiplicative inverse. So the multiplicative inverse of 3 is 1/3. So I have 1/3 times 3x times 180 times 1/3. Because what I do to one side, I have to do to the other. Now, I have 1 times 3x, which is 3x over 3. And I have 180 times 1, which is 180 over 3. So now I know that, I'm going to move this over here. 3 over 3 equals 1, so now I'm going to have 1x equals 180 divided by 3, and that's going to give me 60. So now I know that x equals 60. So to find these angles, I'm going to have 2 times 60, and then here, my angle is just going to be 60. But 2 times 60 is going to give me 120, and now I know that 120 plus 60 gives me 180, which is the degrees of this line. All right, the last one we're doing is exercise 4. The ratio of the angle GFH to EFH is 2 to 3. In a complete sentence, describe the angle relationship in the diagram. So what it means by 2 to 3 is that we're going to have 2x degrees and 3x degrees. Now by looking at this angle here, we have our little box, which means that our angle equals a total of 90 degrees. So when we write out this problem, I'm going to have 2x plus 3x equals 90 degrees. Now let's go ahead and combine our terms. 2x plus 3x is going to give us 5x. So now I have 5x equals 90. To get x by itself, I'm going to multiply 5 by its multiplicative inverse. The multiplicative inverse of 5 is 1/5. And what I do to one side, I have to do to the other. So now I know that when I multiply a number times its multiplicative inverse, I get 1. So now I have 1x. And it equals 90 divided by 5. 90 divided by 5 Go ahead and take out your calculator to solve for that. So 90 divided by 5 is going to give us 18. So now we know that x equals 18. Now to solve the expressions that we have over here, I'm going to have 2 times 18 and 3 times 18. Go ahead and take out your calculators to solve for this. All right, so 2 times 18 is going to give us 36 degrees, and 3 times 18 is going to give us 54 degrees. So answering our question above, so I have the measurement of angle GFH is 2/3 the measurement of angle EF and H. So we know that the measurement of angle GF and H and angle EF and H have a sum of 90 degrees.